Oftentimes, when an analyst is solving a problem, she wants the one exact solution that will optimize the situation. However, there are times when her company may want a range of possible scenarios. These two cases involve solving linear equations and solving linear inequalities. Hi, my name is Tom Atwater, and today we're going to learn how to solve linear equations and linear inequalities. Let's start with the definition of a linear equation. An equation is a statement of equality between two expressions. Here are some properties of equality that we use to solve equations algebraically. Let u, v, w, and z be real numbers, variables, or algebraic expressions. The first property, reflexive, tells us that u is equal to itself, u. The symmetric property tells us that if u is equal to v, then v is equal to u. The transitive property, if we know that u is equal to v and that v is equal to w, then u will be equal to w. The addition property tells us if we have u equaling v and w equaling z, then u plus w will equal v plus z. And the property of multiplication is if u is equal to v and w is equal to z, then u times w will equal v times z. Let's examine this by solving an equation. Solving equations. A solution of an equation in x is a value of x for which the equation is true. To solve an equation in x means to find all the values of x for which the equation is true, i.e., to find all solutions of the equation. Let's actually work an example of where we use this idea. Let's take the example, prove that x equaling -3 is a solution to this equation, 2x squared plus 5x is equal to 3. So to prove that x equals -3 is a solution, what we do is we substitute -3 in place of the x. So what we have then is 2 times -3 squared plus 5 times -3 equals 3. Now, -3 squared means -3 times -3, which of course would be 9, and 2 times 9 is 18. 5 times -3 would give us -15. And of course, 18 minus 15 is 3, and 3 is equal to 3. So what that tells us is that -3 is a solution to that equation. And what's nice about that is when we solve linear equations and you get your final answer, in this case x equals -3, you can check to make sure you got the right answer by plugging that -3, in this case, in for the x, and then simplifying, doing the arithmetic. And if you end up with a true statement, as we did, 3 equals 3, then you know that your answer is correct. Now, the most basic equation in algebra is a linear equation. Now, a linear equation, we know, has a certain form, and let's take a look at that. A linear equation in x is one that can be written in the form ax plus b equals 0, where a and b are real numbers and a does not equal 0. Let's look at some examples of linear equations. For example, if I tell you 2x minus 4 equals 0, that would be an example of a linear equation. But if I had something like this, 3u squared minus 12 equals 0, that is not a linear equation because of the power of 2 on our variable u. Now, linear equations in one variable have exactly one solution. And we solve these equations by transforming it into equivalent equations whose solution is obvious. Now, two or more equations are equivalent if they have the same solution. For example, let's take our original equation, 2x minus 4 equals 0. It turns out that that is the same or equivalent to 2x equals 4. And that's actually equivalent to x equals 2. So each one of these are equivalent to each other. The reason that's helpful is that we're going to learn how to use that idea to solve linear equations. Operations of equivalent that represent equivalent equations. An equivalent equation is obtained if one or more of the following operations are performed. We have combining like terms, reducing fractions, and removing grouping symbols. In this particular case, we have the given equation 2x plus x equals 3/9. And what we do here is we combine like terms. 2x plus x gives us 3x. And we reduce the fractions. In this case, 3/9 becomes 1/3. All right, the second thing we can do is to perform the same operation to both sides of the equation. And we're going to look at the operations of addition, subtraction, multiplication, and division. So we will start with addition. In this case, we're going to add -3 to both sides of this equation. So what we were given is x plus 3 equals 7, and I'm going to add -3 to both sides. And of course, here they add up to 0. So I end up with x on the left-hand side. And on the right-hand side, we end up with 7 plus a -3 is 4. So those are equivalent equations. X plus 3 equals 7 and x equals 4. Now let's look at subtraction. In this particular case, we're going to subtract 2x from both sides of this equation. The given equation, 5x equals 2x plus 4. And I'm going to subtract 2x from both sides. On the left-hand side, 5 minus 2 gives me 3x's. And on the right-hand side, 2x minus 2x, of course, equals 0. So we have equals 4. And again, we have an equivalent equation of 3x equals 4. Now what we're going to do is look at multiplication. If you multiply both sides by a non-zero constant, in this case, we're going to multiply both sides by 1/3. So to do that, I take and multiply the left side by 1/3 and multiply the right-hand side by 1/3. Here, my 3's cancel out to 1. And 1 times 1x is 1x, which we have here. Over here, my 3 will reduce the 12 down to a 4 and a 1 here. So we have 4 times 1, which is the 4. And that's an example of multiplying both sides by a non-zero constant. The final thing we want to look at is dividing both sides by a non-zero constant. In this case, we're going to divide both sides by 3. So what that looks like in this case is 3x divided by 3 and 12 divided by 3. Once again, the 3's reduce down to 1, and we get x. And over here, the 3 goes into 12 4 times, and 3 into itself once, so we get x equaling 4. All right, great. Let's work an example of where we use one or more of these particular operations to create an equivalent equation. So we want to solve the following example. 2 times parentheses 3 minus 4z minus 5 times parentheses 2z plus 3 equals z minus 17. So the first thing we're going to do is apply the distributive property and multiply 2 times 3, which is 6, 2 times negative 4z, which would give me negative 8z. Then we want to distribute this negative 5. And negative 5 times 2z gives me negative 10z. Negative 5 times 3 gives me negative 15. And on the right-hand side, we still have our z minus 17. Now we can combine our like terms. So negative 8z and negative 10z gives me negative 18z. 6 minus 15 leaves me negative 9. And we have still on the right-hand side z minus 17. Now what we want to do is subtract z from both sides so that I can get the z's together. But at the same time, if I'm going to get the z's together, I also would want to get the constant terms together. So what I'm going to do is add 9 to both sides of this. And what that results in is we have negative 19z equals, because this adds up to 0, this adds up to 0, so I get negative 17 plus 9 is negative 8. My final step would be to divide both sides by negative 19. And what result I get, of course, these will cancel out completely to 1, and my minus signs will also cancel each other out, that is to become positive. So my answer will be z equals 8/19. And then you can see by using those different operations, we've simplified it down to z equals 8/19. Now we could take that value for z and plug it back into the original equation, and if we ended up with a truism, that is something at the end that left side equaled the right side, we would know that answer is correct. But I'll leave that up to you. Now, if an equation involves fractions, the best thing to do is to find the least common denominator of those fractions and multiply both sides by that LCD. This is sometimes referred to as clearing the equation of fractions. In our next example, we'll take a look at that. Solve the quantity 2x minus 3 divided by 4 plus 5 equaling 3x. So what we want to do here is take and multiply both sides of this equation by the common denominator 4. So on the left-hand side, we have to distribute the 4. And when we distribute the 4 to the first term, the 4's will cancel each other out, leaving us with 2x minus 3. 4 times 5 gives us 20, and on the right-hand side, 3 times 4 gives us 12x. So now we can combine the like terms of negative 3 and 20, and that gives us 2x plus 17 equals 12x. Now, I want to get the x's on the same side, so I'm going to subtract 2x from both sides. That will give me 17 on the left-hand side, and then 12x minus 2x yields 10x on the right-hand side. Now, we divide both sides by 10. On the right-hand side, the 10 divided by 10 gives me 1, in that case, x, and that means my answer is x equals 17 divided by 10. And sometimes we will want to turn that into the decimal of 1 7/10. And that will be determined by what we would be using that particular answer for. Sometimes the fraction form will be better, sometimes the decimal form would be better. Well, let's revisit inequalities. The most basic inequality in algebra is a linear inequality. A linear inequality in x is one that can be written in the form ax plus b is less than 0, or ax plus b is less than or equal to 0, or ax plus b is greater than 0, And finally, ax plus b is greater than or equal to 0, where a and b are real numbers and a does not equal 0. To solve an inequality in x means to find all the values of x for which the inequality is true. So let's take a look at this. A solution of an inequality in x is a value for x for which the inequality is true. Now, the set of all solutions of an inequality is called the solution set of the inequality. We solve an inequality by finding its solution set. Here are the properties that we'll use to solve inequalities. Let u, v, w, and z be real numbers, variables, or algebraic expressions, and c is a real number. We have the transitive property that tells us if u is less than v and v is less than w, that means u has to be less than w. The addition property, if u is less than v, then when we add w to both sides, u plus w will still be less than v plus w. And if u is less than v and w is less than z, then adding u plus w will still be less than adding v plus z. The property of multiplication tells us if u is less than v and c is greater than 0, then u times c will remain less than v times c. If, however, c is negative, then u times c is going to be greater than v times c. That is to say that we have switched the direction of the inequality symbol. All right, the above properties are also true if you replace the less than sign by a greater than sign. And there are similar properties for greater than or equal to as well. Let's take an example and solve the inequality and draw a number line graph of the solution set. Now remember this, that what we have are all the various properties that we can use to solve this. So here what we're going to have to do is distribute the 2. And when we distribute the 2, we will get 10 minus 6x. And then we need to distribute the 3. And when we do that, we'll get plus 6x minus 3. On the right-hand side, we still have 2x plus 1. And now we can combine like terms. That is, we can take the x's and combine them. And look what happens. They actually add up to 0. We can take the 10 minus 3, and that gives us 7 on the left-hand side. That's going to remain less than or equal to 2x plus 1. Now I subtract 1 from both sides, and I get 6 is less than or equal to 2x. I divide both sides by 2. The 2 divided by 2 gives me 1x. And on the left-hand side, 6 divided by 2 is 3. So the algebraic solution to this is that 3 is less than or equal to x, or using the reflexive property, we can say that x is greater than or equal to 3. X is greater than or equal to 3. Now, the graph of this is a number line, which I want to draw here, so I need to create space. So remember, our answer is x is greater than or equal to 3. And as I said, we want to draw a number line, give our reference point of the origin 0, then label our point 3. And now for x greater than or equal to 3, we use a bracket at 3 exactly. And then we shade in the number line with an arrowhead going out to the right to show that all the values for x that are from 3 and beyond satisfy that inequality. All right, great job with that. Now, sometimes two inequalities are combined in a double inequality, whose solution set is an equality with x isolated as the middle term. Our next example illustrates this. Solve the inequality and graph its solution set, and we have negative 3 is less than 2x plus 5 quantity divided by 3, and that's less than or equal to 5. So let me create some more room here, and we're going to solve this both sides simultaneously. So the first thing that I'm going to want to do is multiply by that LCD on the left side, on the right side, as well as in the middle. On the left-hand side, of course, 3 times negative 3 gives me negative 9. In the middle, we are multiplying by 3 because we want to be able to say that 3 divided by 3 gives us 1, which means we have negative 9 is less than 2x plus 5. And that's less than or equal to 3 times 5 is 15. The next thing we would do is subtract 5 from each of these terms. In other words, we want to isolate the x in the middle, so we subtract 5, but we need to do it to all 3 parts of our inequality. What that leaves me, negative 9 minus 5 is negative 14. That's less than 2x because 5 minus 5 is 0. And that's less than or equal to 5 minus 15 gives me 10. The final operation is to divide both sides by 2. Or I should say all 3 parts by 2. And negative 14 divided by 2 is negative 7. Less than 2 divided by 2 is 1x, which is less than or equal to 5. So our algebraic solution is negative 7 is less than x, which is less than or equal to 5. To graph that, we need to draw a number line as we did before. Now, there's a difference here when we get to the number line, and the difference is that here we have a less than sign. Here we have less than or equal to sign. When we go to draw the graph, a less than sign without the equal to part means that negative 7 is not included in the answer, and we will use a parenthesis to represent that. Whereas we've already seen that when it has the equal to part, we use a bracket. So let me clear the screen and rewrite my solution, which was negative 7 is less than x, which was less than or equal to 5. And now we draw the number line. Here's 0, here's 5, and here's my negative 7. And now what we do is we know that we're going to have an open parenthesis at 7 because 7 is not included. We have a bracket at 5 because it is included, and it is all the values between negative 7, exclusive of 7, and inclusive of 5. And that would solve the original inequality. Well, now it's time for you to try a problem. I would like you to do the following problem. Solve the inequality and then graph its solution set. 0 is less than or equal to 2z plus 5, which is less than 8. Pause the video while you work on this problem, and when you're finished, restart the video to check your solution. Let's find out how you did on this problem. You needed to first isolate the z in the middle, and so to do that, the first step would be to subtract 5, and we would have to do that to all 3 parts. So that gives us negative 5 is less than or equal to 2z, z, not x, which is less than 3. Now we need to divide all 3 parts by 2. Over here, we just leave it as negative 5/2, which is less than or equal to 2 divided by 2 is 1, which gives me z, and less than 3 halves. So we need to graph this, and in this case, to graph it, realize that we're going to use brackets and parentheses again because we have less than or equal to here, and over there we just have plain old less than. So our solution for the graph would look like this. Here's 0 as my reference point. Here's 3 halves. This would be negative 5 halves. This time I use a bracket for the negative 5 halves, a parenthesis for the 3 halves, and then I shade in everything in between, and that's the answer that you hopefully got when you worked out the pause video for yourself. All right, great job in today's lesson. What we learned today was how to solve linear equations and linear inequalities. Be sure to work the exercises that your teacher assigns, and we'll see you next time.